This video focuses on high and low pressure patterns and how the Coriolis effect can impact larger wind patterns. Remember, wind always travels from areas of high pressure to areas of low pressure because the Earth is trying to even things out. In the diagram, we can see that the wind is traveling out of the high pressure in the Rocky Mountains and into the low pressure near the Appalachian Mountains. However, if you notice, the wind is not traveling in straight lines. This phenomenon is due to the Coriolis effect. You will also notice that the wind circulates in a clockwise motion around high pressure cells and counterclockwise around low pressure cells. On the right hand side of your notes, make sure that you answer the questions about high and low pressure. Pause the video to complete this question before you go any further. The Coriolis effect is an inertial force described by the 19th century French engineer-mathematician Gustave Gaspard Coriolis in 1835. Coriolis showed that since Earth is a globe, rotational speed is fastest at the equator and slowest at the poles, meaning the equator has to travel more distance in the same amount of time as the poles. The land under the air masses leaving the poles increases speed as it moves towards the equator. As a result, the air mass appears to veer to the right in the northern hemisphere and to the left in the southern hemisphere. This is called the Coriolis effect, and it does work for water as well. So this video is of the Coriolis effect. You have two MIT students demonstrating sitting at either end of a rotating platform, and they're going to toss the ball back and forth. When viewed from the rest frame, when the camera is mounted on the ground, the ball will follow a straight line but doesn't reach its target because during the ball's flight, the target rotates away. When viewed from the rotating frame, when the camera is actually mounted on the rotating platform, the ball appears to experience a force that pulls it away from the target. This curved trajectory in the rotating frame is known as the Coriolis effect, sometimes called the Coriolis force, though it disappears in the rest frame. The Coriolis effect can be seen in many situations where rotating frames are encountered, especially in meteorology and astronomy. Atmospheric systems, for example, often follow circular patterns due to the Coriolis effect. Airplanes and missiles appear to follow curved trajectories when seen by observers on Earth as the planet rotates underneath it. Over on the right-hand side of your notes, draw in the wind direction for both high and low pressure systems. Remember, wind always travels from high to low pressure. Pause the video and complete this before going any further. Hopefully you had air moving out of the high pressure and into the low pressure. High pressure, you should have counterclockwise motion, and low pressure, you should have clockwise motion. The pictures you drew are of surface level wind. High and low pressure systems work together both at the surface and in the upper atmosphere. As air comes together in the low pressure system at the surface, it has to go somewhere. Remember, low pressure air is usually warmer than the air around it. This means that it's less dense and should rise into the upper atmosphere. This air then cools and condenses to form clouds. Once in the upper atmosphere, this air can then spread apart or diverge and move into a high pressure cell. Now that the air is cool, it converges in the upper atmosphere and sinks due to its high density. As this air sinks, it warms up and is dry, not allowing any clouds to form. Once the air hits the ground, it can then move back into the low pressure cell, completing the cycle. Before moving on in the video, make sure you answer the questions on the right-hand side of your notes. So as a quick little review, in a high pressure area, air will sink because the air is more dense. This is because the air is cold or cooler than the air around it, and cold things always sink. Therefore, clouds cannot form in a high pressure area. Whereas in a low pressure area, air will rise because the air is less dense. This is because the air is warmer. Remember, warm things always rise. Therefore, we get clouds in low pressure areas. Now, although this is not in your notes, it is a great visual to review the difference between high and low pressure systems. Low pressure system, the air is warm. It rises due to its density, making clouds form. The air rotates counterclockwise in a low pressure, and the air moves into the low. High pressure systems are pretty much the complete opposite. I would recommend finding a place for this in your notes to use in the future. That's all for this video. Make sure you review and complete any summary questions.